Alright, ladies and gentlemen, we're going to talk about pH calculations and how to name some acids in a little bit. Alright, instead of writing out concentration of something in this unit, we're going to use these little bracket guys to shorten things up. So if we put a bracket of anything, that thing in there means it. So down here, bracket of OH minus means the concentration of hydroxide. So two common things we've talked about before are concentration of hydroxide, concentration of H plus or protons. Those are two common ones we'll see throughout the unit. You've seen before, you'll see a lot again as we keep going, talking about acids and bases. So just remember, that's our shorthand for chemists for meaning concentration of that thing. Okay. So the pH of a solution is based on how much H plus, how many protons there are in the solution, and it's based on a logarithmic scale. Now, if you didn't like logs in math, or if you haven't done them yet, don't worry. I'm going to walk you through an easy way to do it. I didn't like them much either. So if you know the concentration, the molarity basically of the H plus you have, you can find the pH by taking the negative log of it. Luckily, all of your calculators will do this for you. So you have a really, really basic one. So if you take the negative log of the H plus concentration, that's what the brackets mean, you get the pH. So the log button is just on the calculator. So the question is, what is the pH of a solution with the H plus concentration of 0.00015? You simply take, on your calculator, you take negative log, type that in your calculator, then put in 0.00015. It equals, and you should get one of these answers. Some of your calculators, if you're using like an iPad calculator or an old calculator, may not have, and let's use the inverse button easily, the negative button. You could just take the log of this number, then take the opposite, the negative version of it. That's okay. When you do this, you should get 3.82. If you don't, you probably missed something along the way. Make sure you're getting 3.82 when you solve this. If you did, awesome. If not, let's try it again and check out, see if you're missing a 0 or adding a 0. Make sure it's positive and not negative. Alright, below you're asked what the H plus concentration is, or was, in the solution when you already have the pH. Alright, so now we already know the pH, we don't know the H plus concentration. It's like going backwards. Now we can't use the negative log because that's when you go the one way. We have to do the opposite. What's the opposite of a log? And don't tell me a tree. That's not what I mean. The opposite of a log is taking 10 to the negative pH. So same idea. So 10 to the negative pH will get you H plus concentration. Technically, 10 to the negative anything just undoes pH, or P anything. So also 10 to the negative POH also gets you OH minus concentration. So it's pH power, or POH power. So if that's a question, note this question down here. What's the H plus concentration of a solution where the pH is 12.4? So give it a shot. It should come out to one of these four answers, hopefully. Give you a second to calculate. Unpause, or pause if you need to, then check your answer. Hopefully you get the pinkish one. Okay, but now if you're told the pH of the solution is 3.4, they may also want to know what the POH is. So this is pretty much checking on how the pH checks how acidic the solution is. The POH basically checks how basic it is. It's an odd measurement of things, but it's checking the opposite version of it. This scale is actually the easiest mathematically by far, because pH plus POH equals 14. It's very simple algebra. If we know pH equals 3.4, and we know they have to add up to 14, we just have to do a little bit of subtraction, and we get POH equals 10.6. That'd be a useful and easy one to know. So if I tell you we're asking for the pH of a solution, and we know the POH is 4.9, you should be able to tell me really quick which one it is, and a couple of them should be obviously wrong. So if you need to pause, feel free. Solve for it. What color is it? Now you've unpaused. You hopefully got, yay, green. Right. We can also look at the OH minus concentration, the hydroxide ion concentration we have in solution. Same thing we did, or same way we did with the proton concentration. So when we took the negative log of H plus, we got pH. We take the negative log of OH minus, we get POH. So I said negative log of something just gets you the P version of that same thing. The P basically is the log version of it. So what is the POH of a solution with the OH concentration of 0.000085? There are your color options. Pause, give it a shot, see what you get. Hey, you're back. Did you get color red, hopefully? If not, let's try and figure out why, or try it again. Come with questions if you got them. You can also go directly from H plus to OH minus. I think this is the only one here in my class. Only formula that's not directly on the back of your periodic table. But you do need to know that the H plus concentration, this looks kind of weird because it's underlined in there, so ignore this bottom one, H plus concentration times OH minus concentration equals 1.0 times 10 to the negative 14th. So if we know the H plus, or we're looking for the H plus concentration, and we know the OH minus concentration is 0.00055, we can plug in the OH minus concentration and solve for the H plus concentration with algebra. Same idea, give it a shot. Try and find out which of the four colors, which of the four answers it would be in this case. Now that you're back, hopefully you got green. If you didn't, let's try to figure out why and fix it. Okay, so all these come together, if I can get this out of the way, to make what I call a pH polygon. Technically, it's kind of like a roadmap or a treasure map of saying, hey, if I have this thing, but I want this thing, I can use this formula going from here to here, this formula, and then this formula to get there. Now, you'll be able to use this on your actual quiz or test, but it's a good thing to get practice down if this is confusing to you. If it's not, then don't worry about it. If this is a useful piece, useful tool along the way, go for it, take advantage of it, take a screenshot, take a picture, use it along the way. But make sure this makes sense before you get to the quiz or test, and make sure it's useful when or where you need it. Okay, check question. Give it a shot on your own. And see if you find that joke amusing. I did. Okay, there's your question. Pause if you need to. Hope I didn't give you an answer. I should probably calculate that quick. Sorry about that. Okay, so you should have got an answer to this question of a pH of 9.16. Sorry, POH of 9.16. If you're getting that, you're probably in pretty good shape, and the practice should not be too hard for you. Okay, then just to clarify, strong acids versus weak acids. This was covered a little bit earlier, but hopefully it makes sense. An acid's strength is determined by how much of that H plus leaves the acid. So how much dissociates, how much breaks apart from the compound. Weak acids, very little of it actually breaks apart. The molecule mostly stays together in one big chunk. So just a little bit breaks apart, but like most of the compounds, most of the molecules stay together. So acetic acid, hydrofluoric acid, water, they mostly stay together as one compound. Most of those H's in H2O stay as H2O. Most of the HFs stay connected. Strong acids fully dissociate. Every single H in there disconnects from the rest of the molecule. So HNO3, all the H's disconnect from the NO3s. H2SO4, it loses the H's come off all the time. HCl, all the H's, all the Cl's separate when they're in water all the time, 100% of them. That's how we define a strong acid versus a weak acid. It's how soluble they are. If they're fully soluble and they fully dissociate, fully break apart, that's a strong acid. So here's an interesting question. What would have a lower pH? A 100 milliliter container with 100 HCl molecules in it, or 100 milliliters with 500 HF molecules in it? Pause, think about it. Let's see if your answer matches. Okay, so 500 HF molecules, this is a weak acid, so 5% of these dissociate. So we take 500 times 5% means we've got 25 H plus ions in there, so protons in there. But 100% of the HCl dissociates into a strong acid, so you have 100 protons here. So you got 4 times more protons from this dissociating or in this solution. So this has a pH of, will have a lower pH because there's 4 times more protons even though there's less molecules in there. So the stronger acid, you have to have 1/20th or 20 times more of a weak acid in solution to make it a lower pH. That's what that means. Hopefully it makes sense. If it doesn't, let me know, ask some questions, shoot some emails. Okay, acid and base when we combine them. If you have 200 milliliters of an 8 molar base solution and want to make it a 2 molar solution, to what final volume must we add the water? So this looks a lot like our dilution formula you may have seen before when we did solubility. So our molarity is going to be 8 molar. Our volume's 200 milliliters. We want to get it to be a 2 molar solution. We've got to get our new volume to be what? A little bit of algebra here. Which all keep in to be a base here. No big deal. We dilute it. We should get 800 milliliters. Hopefully that's straightforward. Run the math. Check it out on paper. Make sure it works out for you. This one gets a little trickier. If you have 300 milliliters of a 12 molar acid, so 300 milliliters here, 12 molar HCl, and you want to make it a 1.5 molar solution, how much water must you add? That is the key word. So give it a shot, pause it, try it. Now that you're back, hopefully you got pink. Some of you probably said blue though. Now look, we're talking about the 2400 milliliters we'll need total, but 300 milliliters of that came from the acid we already had. So the water we add is only 2100 milliliters, not the total 2400 milliliters. Hopefully that's clear. Alright, the last one. If we have 700 milliliters of a 5 molar base, how much of a 3 molar acid must you add to neutralize the solution? So if you remember, acids and the bases mix, they're neutralizing. They're making a high pH and a low pH mixing to make it close to get it back to 7. The moles of the acid and the moles of the base will be even in the end, so we have no extra H pluses, no extra OH minuses in the end. They all even out. That's what the M1, V1, M2, V2 will, how it works with acids and bases. You gotta get the right amount of volume of our acid here to make them be even, which when you run the numbers should get you 1,167 milliliters. Hopefully you got that right. Let's name some acids. Right. One of your last things of naming for the year, we did ionic and covalent naming earlier this year. Actually, we'll come back. We'll do this in part 2.